Hello class, welcome to another lecture by Professor Choi. Today we're going to be talking about what exactly is the technological advance in economics, the production function, and costs of production. So technology in economics is the process by which that a firm uses to turn inputs into outputs of goods and services. So in a basic way, technology is the magic that companies use in order to turn an input into an output. Let's try and visualize that. So inputs of production are basically what you need to get in order to produce. In other words, the particular raw materials and things and machinery that you need to have in order to produce. We call them factors of production in economics. So you can think of them as land, labor, capital, and entrepreneurship. All right. So land represents raw materials. Labor represents the people that work there. Capital are the machines and the equipment that you need to use in order to produce something. And entrepreneurship is basically the person who started the business, because pretty much everything was started by someone. That could be the government, but it could also be an individual. All right. Then with those inputs, you kind of take the inputs and you run them through technology. All right. Now, technology could be a process. Technology could be a process that includes all these machines, all the labor, all the specialized knowledge, etc., etc. But basically, you take all the inputs, you kind of shove it through this process, which we call technology, and out of it comes the output. Now, to simplify things, output for us is going to be in quantity. So we're going to talk about quantity of production. And then at some point, you got to take that quantity and you got to sell it. So we're going to talk about prices. And production costs you money. So we're going to talk about costs as well. So prices, sales, what we call revenue or total revenue, all of that is sort of coming right now in the next chapters, this one and whatever follows. All right. Now, at some point today, we're going to be trying to establish the basic costs of production. So the costs of production and we're going to be talking a little bit about profit maximization. So kind of like the way companies try to maximize their profits by producing at the lowest cost possible. And they do that by trying to find the most efficient area of production given certain assumptions. Okay? So we're going to be talking about efficiency. All of that today. All right? Now, we're going to talk about some point about what we call the production function. So basically, an increase in technology, what it does is it kind of shifts your production function upwards, or it shifts your cost structure downwards. A technological change is basically the ability of a firm to produce a given level of output with a given level of inputs. So when there's an increase in technology, the idea is that you will be able to produce more outputs with the same amount of inputs. Okay? All right, now before we engage in that conversation, one of the things that we need to establish is time periods. This particular chapter, usually you would kind of look at it before you engage in what we call the four-firm model, which follows after. So the four-firm model includes perfectly competitive companies, monopolistic competition, oligopoly, and monopoly. And every time you study those structures, we try to separate it into two time periods. The two time periods are the short run and the long run. The short run is a period of time in which at least one of the firm's inputs is fixed and the other one is variable. Now, for simplicity purposes, what we're going to do is we're basically just going to talk about labor and capital as the inputs to production. And we think of land and entrepreneurship as endowments. So in other words, you are given those, you can't really change those, but you can definitely kind of work on your labor and your capital in the short run and in the long run. All right, so what exactly is a short run time period? So a short run time period is a time period where labor, where labor is variable but capital is fixed. All right, now how do we visualize this time period? Well, in the short run, if you have a company, you basically have this production capacity. I want you to think about this being like the size of your factory. You cannot really change the size of your factory in the short run. That's what we're basically saying here. So your capital, your machine, your equipment, the things that you use, the process that you have, you can't really change in the short run. Capital is fixed. But labor is variable. So in the short run, your input decision, in order for you to be able to produce more or produce less, is basically to hire or to fire. Now, we don't have to just talk about hiring and firing, but we can also talk about allocating more hours of production or cutting back hours of production. But the whole idea is that in the short run, the production function and cost structures are basically dictated by labor changes, not by capital changes, because capital is fixed. All right, then we get into the long run time period. The long run time period is some point of in the future where labor is variable, but you can also change the size of your capital, aka you can get new machines, new equipment, a larger factory, etc. And you may even be able to change technology. So in the long run, all inputs are variable. Okay? So all inputs to the production process are variable. That basically means that you can change anything, and therefore your ability to produce changes as well. So the analysis is different. One of the things that you're going to notice as you are studying the four firm models is that we're going to engage in a conversation where we talk about the short run, and then at some point we talk about the long run. All right, so let's introduce you first to the cost of production. Now, we're trying to be simplistic here, by the way, because we're kind of establishing a theory of behavior. So a lot of it is basically fairly simplistic. So when we're going to talk about cost of production, we're basically going to say that total cost is the cost of production, and it is composed of two types of costs. One cost is what we call variable cost, and the other cost is what we call fixed cost. A fixed cost is a cost that you cannot change. And doesn't matter how much you produce, whether you're producing 100 units or 0 units, you have to pay that fixed cost. And a really good example of a fixed cost is rent if you have an office, for example. So whether you are open or you are closed, you have to pay rent. All right. Another example of a fixed cost are things like salaries. I guess it's a bit of a stretch, but it's if you have particular workers that you really cannot get off payroll, then that will be another example. But in any case, the best example of fixed cost is something that does not change, something like rent. All right, now the best example of variable cost is basically a cost that changes as output changes. A really good example of that is hourly wages. So if you don't want to produce anything, then you basically don't have any variable costs because you don't have to hire anybody. But you do have fixed costs. Now, the more you want to produce, the more you have to hire people and the more you have to buy inputs to your production process, especially some of those raw materials. So a variable cost is a cost that changes as production changes. So if you are at production equal to 0, then there is no variable cost. But if you are at production equal to 100, variable cost will be higher. All right, we like to use a lot of graphs, by the way, to represent a lot of these stuff because we think it's easier. That may not be true, but economists think it is. So let's put quantity of labor on this side. No, sorry, quantity of production. So quantity of product on this side, and on this side let's put cost. All right, let's try to graph a fixed cost. Now, a fixed cost is a cost that doesn't change regardless of where are you producing on this quantity. So if you decide to produce here, you still got to pay the same. If you decide to produce here, you still got to pay the same. And again, a really good example of that is rent. So let's say you have a small office and you pay $1,000 in rent. Okay, so this is what we call your fixed cost. All right, notice again that your fixed cost is the same along the quantity. So it doesn't matter how much you're producing, whether you're producing 0 or you're producing 100 units, your fixed cost is 1,000. All right, now variable cost doesn't have this straight line shape. Variable cost increases at an increasing rate at the beginning of production. Then at some point it kind of like flattens out and it increases at a decreasing rate. And then at some point it goes up again and it sort of skyrockets. This is the general graph for variable cost of production. All right, now our total cost of production is going to be equal to variable cost plus fixed cost. And because fixed cost is the same all the time, then your total cost line is basically going to follow the same shape as your variable cost line. But the difference at any point between those two lines is going to be 1,000. Okay, so the vertical difference here, which is 1,000 in this case, and the vertical difference here is going to be 1,000. The difference between total cost and variable cost is fixed cost. All right, but the shape of total cost basically follows the shape of variable cost. Now imagine that you were a company again and you were trying to produce at a sort of more efficient area. During this point here, where costs are increasing at an increasing rate, it is not the most efficient point of production. So stopping around here will be too costly. Somewhere around here, you become more efficient. So efficiency happens anywhere between here to about here on cost. Because notice that your output of product is growing faster than costs are growing. And that's what this line basically shows. Now over here, before you get to that point, your costs are growing faster than your output is growing. All right, so a more efficient area of production is somewhere around there. And I'm gonna put an asterisk, not because this is equilibrium analysis, but because this is a more sort of efficient area of production. All right, this is a general graph for total cost, variable cost, and fixed cost. Now, one of the things that we always like to talk about in economics is what we call opportunity cost. Opportunity cost is a cost that you should add to pretty much everything. Opportunity cost is the highest valued alternative that must be given up in order to engage in any activity. And everything you do pretty much all the time has an opportunity cost. So accounting costs only take into account explicit costs. In other words, something that happens, a check, an expense. But implicit costs include opportunity costs. So when we're talking about costs in economics, we're not only talking about explicit costs, aka accounting expenses, things that are costing you money, but we're also talking about implicit costs, which sometimes may be non-monetary. A really good example of that is efficiency. Okay, so when we're talking about opportunity costs, the best example is lack of efficiency. So the next thing we need to talk about is what we call the production function. Now, the production function is basically a relationship between the inputs employed by a company and the maximum output it can produce with those inputs. So the production function is a relationship So the production relationship between inputs and outputs. Now output, we're going to be calling here product because we're talking about the production function. So the production function is a relationship between the quantity of labor and product. All right. In order to build a production function, we like to use this law called the law of diminishing returns. The law of diminishing returns is basically the principle that says that at some point, adding more of a variable input, like labor, to a fixed input, like capital, a plant, a facility, will cause the marginal product of the variable to decline. So in other words, the more and more workers you add to your production facility, the less and less each one of those workers will bring you in product. And remember, product right now is output. So marginal product tends to have this general shape. All right. Now, total product we're going to use TP for total product. Total product has to do with this marginal and these sort of inflection points. So total product increases at an increasing rate until we reach this point, call it 1. And then it increases at a decreasing rate, and then it flattens out. Right? So let's call this 0.2. This 0.2. Alright, let's use some numbers here so we can visualize what total product is and what marginal product is. So let me put some numbers on this graph here. All right, again, no, we're going to oversimplify this. So imagine that I'm hiring 1 worker, 2 workers, 3 workers, or 4 workers. So this is my total product line. Okay. A bit of a reminder, by the way, about total product and marginal product, in case you haven't been following along with the other lectures. So remember that the word marginal means the additional unit. So marginal product is basically the change in total product. So if I say marginal product of any n being any of these, okay, any of these quantity of labor. So marginal product of any n is basically total product at unit n minus total product at unit n minus 1. All of that divided by quantity at n minus quantity of n minus 1. All this is like fancy talk for saying the change or the additional product. Okay, let's put here 5, 10, and 20. All right, now total product, and again, this in case you haven't been following the previous lectures where we've already defined what the word marginal and the word total mean, but basically marginal is the change in total, and total is basically the summation of the margins. So total product at unit n is basically the summation 1 to n of all the marginal products. All right, and then now we have an extra product. In this case, we have average product. In this case, average product of labor, which is basically total product divided by quantity. And this is what we call productivity. Okay, so average product is productivity. All right, in any case, let's try to put this together. So let's come up with a table here where I got my quantity of labor. All right, again, remember to visualize this. What we're basically doing now is imagine what the product, the output of a company is. A very simple company that hires people or fires people in the short run. And we're moving from hiring the first worker to hiring the 4th worker. All right, Now my marginal product is the product of each individual worker. So if I hire no one, then I have no product, okay? Because no one gives me no output. Total product is the addition of all the workers that I have, but if I hire no one, I got no product, okay? And then average product will basically be whatever total is divided by Q, which in this case is still 0. All right, so let's hire the first worker. When we hire the first worker, that individual gives us, according to this graph that I drew, that individual gives us 10 product. Okay, so we go to this at 1, that individual gives us 10 product. Because I only have one individual hire right now, my total product is 10. And my average product is whatever total is divided by Q. So it will be 10 divided by 1. In this case, 10. All right, but if I hire my second worker, notice that my second worker is more efficient than my first worker. So my second worker gives me an output of 20. Now my total product is now going to be the addition of the output of the first worker plus the product of the second worker, or 30. And hence the formula here, that total product is the addition of all the marginal products. All right, average product is total, which is 30, divided by the quantity of labor, which in this case is 2. So it will be 15. All right, if I hire my third worker, notice that because of the law of diminishing marginal returns, my output per worker peaks at a certain point and then it decreases. So now my third worker gives me the same amount of product as my first worker did. So my marginal product of that individual is 10. My total product is the addition of all the marginals all the way to here, so it will be 40. And my average product will be 40 divided by 3. And that's 13.3. All right, now if I hire my fourth worker, marginal product in this case will be 5. So the fourth worker gives me a 5 product or 5 output. My total product will be 45. And my average product will be 45 divided by 4, or 11.25. All right. Now we can also graph average product, and average product kind of looks like this. Okay. Notice that, by the way, that it peaks basically somewhere on here. All right. Now, why is this analysis of the basic production function important? So the reason is because what we want is the highest productivity per worker. Because that basically means that the average of product of all the individuals that you have hired is at the highest point possible. Notice that the highest point possible on my production function is somewhere around here. Okay, so notice that it doesn't happen at the beginning of production, and it doesn't happen towards the end of the production function. It happens somewhere in the middle of the production function. So in order for you to be very efficient, you would have to produce somewhere in here where productivity per worker is at its highest. somewhere around there. And this will be the amount of workers that you would hire. Okay? All right, let's move on to per unit cost. Every time we do this sort of analysis in economics, we like to do it by thinking about changes of unit by unit. And hence, a lot of the times, we have to turn things from totals into averages or changes so that we can talk about adding a unit of production or subtracting a unit of production. All right, so marginal costs are the change in the firm's total cost from producing one more unit of a good or service. The marginal cost is basically change in total divided by the change in the quantity of one unit. Average total cost is total cost divided by quantity. All the other average costs, which are per unit costs, are basically cost divided by quantity. All right, now to understand per unit cost of production, let's start back in this formula here. So when we kind of set up this cost of production, we were talking about sort of the total cost of production. But we now want to talk about per unit costs of production. So we can analyze the behavior of adding units of production or subtracting units of production. Okay? So how do I turn a total cost into a per unit cost? Well, all we do is we take total and divide it by quantity, and now it becomes average total cost. Okay? We can take also fixed costs divided by quantity, and it becomes average fixed costs or per unit fixed costs. We can take variable costs and divide it by quantity, and then it becomes average variable costs. And then we can talk about marginal costs, which is the change in total cost of one unit of production. So it's total cost at unit n minus total cost at unit n minus 1 divided by Qn minus Qn minus 1. Alright, now to visualize per unit cost of production, I have this Excel sheet here. This Excel sheet is from a fictitious company. Now this fictitious company has a fixed cost of production of 135. So if you were to produce nothing at Q0, your total cost will be 135. All right. Now, after the first unit of production, after you hire the first worker, in order to produce the first unit of production, we need to pay our fixed cost, but we now have to pay our variable cost. So my total cost is going to be equal to fixed cost plus variable cost. So this TC is basically equal to FC plus BC. Okay, so TC, this formula here, equals FC plus BC. Okay, that's how I came up with these numbers here. So if you come over here to this 615, I get this 615 by doing fixed cost plus variable cost. All right, now how do I turn this cost into per unit cost? Well, average fixed cost is basically equal to whatever fixed cost is divided by Q. So in order to get this number here for average fixed cost, I take fixed cost and I divide it by Q. So this 135 is this 135 fixed cost divided by Q, which is 1. This 67.5 is fixed cost divided by Q, which is 2. This 45 is fixed cost divided by Q, which in this case is 3. Okay? The average variable cost, or ABC, is equal to variable cost divided by Q. So in order to get all of these costs here, what I'm doing is I'm taking variable and dividing it by Q. So this 30 equals variable divided by Q. This 27 is 55 divided by Q. This 25 is 75 divided by 3, and so on. Alright, now to calculate average total cost, I'm doing total cost and I'm dividing it by Q. Okay, so in order to get this 40.71 that you see here, what I'm doing is I'm taking my total cost, which is this number here, 285, and I'm dividing it by 7. In order to get this 55 that you see here, I'm taking my total cost and I'm dividing it by 4. Alright, to obtain this marginal cost here, I'm looking at the change in total. So this 30 is the change between this 135 and this 165. This 25 is the change between 190 and 165. This 20 is the change between 210 and 190. This 10 in marginal cost is the change between this 220 and this 210. So marginal costs are the changes in total. First change is 30, next change is 25, next change is 20, next change is 10, next change is 10. Good so far? Alright, so here's what the graph would look like if you're graphing the total cost, fixed cost, variable cost compared to Q. So in order to come up with this graph, what I basically did is I took this here and I graphed them, with Q being on the horizontal axis and then the costs being on the vertical axis. All right, now to look at the per unit cost, this is a graph of the per unit cost. Okay, so this line that you see here in purple is marginal cost. This line that you see here in red is average variable cost. This line that you see here in blue is average fixed cost, and this line that you see here in green is average total cost. All right, interesting to notice that the average variable cost and the average total cost cross the marginal cost at their lowest point. So they're kind of U-shaped and they cross this line at their lowest point. All right. Here's an example of both of those put together. Okay. Now I like to make my graph when I'm graphing costs. I like to exaggerate some shapes a little bit so that it's easier for us to identify. So, for example, I like to put my fixed cost, my average fixed cost, kind of like this. So this is my average fixed cost. I like to make my marginal cost very, very steep. And again, that's to identify that, identify that one. Okay. Now variable cost basically looks like this. So this is average variable cost. And average total cost looks like this. All right, just as a word of warning, some books like to graph it like this. And again, just this, a lot of this is for simplicity purposes, so that people don't get too confused with all these lines. Okay, so they put the average fixed cost here. Notice that the lines don't cross, and that's basically the difference. So instead of the actual cross you see here, they basically just don't cross them and make it easier to see. This becomes average variable cost, this becomes average total cost, and this becomes your marginal cost line. All right. Now, why do we like to graph things versus just, explain them with numbers? Well, let's pick a quantity of production. So let's say that we produce at this quantity right here. Let's say that this is, 100 pizzas. All right. Now, because we're using these graphs, we can easily identify costs of production. So my fixed cost per pizza will be here. This will be my average fixed cost per pizza at 100 pizzas produced. At the same 100, I can go to the average variable cost line, and straight left, I'm going to find my average variable cost at 100 units. If I want to figure out what my cost per pizza is, I come over here to my average total cost, and the number that you have over here is my cost per pizza, or my cost per unit. And if you continue to go up here and you touch marginal cost, then you will get your marginal cost, or your change in cost, at 100. Okay. Now, alternatively, let's pick a different point of production. Let's say instead that I want to produce over here. Okay, somewhere around here. Let's say that this production point is 90. All right, notice that at 90, my average fixed cost is a little higher, but my average variable cost is a little lower, and my average total cost is a little lower. My marginal cost is also lower. At 90, I'm actually more efficient than at 100 because my cost per unit is lower at 90 than it is at 100. All right? Now imagine also that we could put another line, and that line represents the price that we can charge for each pizza. Okay, so this is our price level. All right, our price level here are represented in lava color. Okay, our price level per pizza will tell us how much money we're actually making. Now imagine that at 100, my cost per pizza is $7 each. I can sell them at 10, so my profit per pizza here will be 3. Okay, now at 90, production 90, notice that my cost per pizza is a little lower. I don't know, let's call it $6.50. So that means that my profit is a little higher. The difference between these two numbers. So at 90, I'm making $3.50 per pizza, while if I'm producing at 100, I'm only making $3 per pizza. Now, if you want to maximize sales, you could produce 100 because you'll be making more sales, but at 90, you're making more profit Profit, and we'll talk about this in subsequent chapters if you're following my movement of chapters. Profit is basically total revenue minus total cost. So sales are important, but costs are also important if what you want to maximize is profit. Okay? In the subsequent chapters, we're going to be talking about total revenue as basically the price of the product times the quantity of the product that you produce. So if you produce, say, 100 pizzas and you sell them for $10, that will be your total revenue. And then your total cost will be average total cost at whatever quantity you decided to produce. So average total cost at whatever that quantity is, times quantity that you produce. Okay, so in the case of production 100, ATC total cost will be equal to 7 times the 100 that you produce. Okay, again, that's assuming you want to produce here about 100. All right, now one of the analysis that we're going to be engaging in the subsequent chapters is where should you be producing? In other words, what is the most efficient point of production? Notice that the most efficient point of production is somewhere around here. Now, why is that? It's because the cost per unit is at its lowest when they touch the marginal cost line. So whenever the average variable cost and the average total cost touch the marginal cost lines, is somewhere around there is the most efficient point of production, because you get the highest separation, the highest profit. All right. In any case, one of the biggest thing you need to remember from this particular chapter is the graphs of costs. So you need to remember that average fixed cost looks like that. You need to remember that marginal cost looks like that. That average variable cost looks like that. And that average total cost looks like that. And that they cross marginal costs at their lowest point. So that's the lowest average total cost, and this is the lowest average variable cost. All right. Now, all of the analysis that we have been doing for the last 50 minutes or so, it's in the short run. Let's have a conversation about the long run. All right, before I go over there, by the way, I want to give you another second here, this one, in case you wanted to kind of ponder a little bit more on this one. So this is just another example of how you can take a table of costs and turn it into a per unit cost. All right. Notice also again that the most efficient area of production is when the average total costs are at their lowest. So somewhere around here, anywhere between say 400 to around 600 pizzas is the most efficient area to produce, because your cost per pizza is at its lowest. All right, let's talk about the long run. Again, in case you forgot, because I know we've been talking for about 15 minutes now. So in case you forgot, the long run is the time period where all inputs to the production process are variable. So the long run is a time period where labor, capital, and technology, all the inputs to the production process, are variable. So that basically means that in the long run, you can go ahead and get a new factory, change your production process, etc., etc. All right, so let's kind of visualize the long run. The long run is a time period where you will take advantage of anything you can in order to maximize your profits and your output. So I want you to think about these as being a subsequent opening of multiple restaurants. And each one of these lines represents your cost of production. Okay? So when you open your first restaurant, and think about, again, this is being like your first restaurant, okay? So this ATC1 you see here is the ATC of the first restaurant that you open. It's this ATC here. So first restaurant that you open, you're gonna be on this cost structure. All right? So you're gonna produce more and more and more and more pizzas, and then you're gonna try to maximize by minimizing costs, and at some point it starts going up, and then you decide to expand. So you open a second restaurant. Now, one of the things that you notice as you grow is that your costs per unit decline. And anyone who is into production, by the way, will tell you that this happens pretty much all the time. This is what we call economies of scale. So the bigger you are, the cheaper per unit things are. All right? Now, economies of scale happen for a really long time. So you can open another restaurant, another place, and then you will experience economies of scale. Now, at some point, though, those economies of scale end, and then you will experience dis-economies of scale. Now, how long does this take? In other words, how long does this economies of scale last, and then eventually you experience the dis-economies of scale? Well, that depends. Some companies could take 80 years to get to efficiency here, and then 20 to 30 years to go on the negative side of the curve. Out of the top of my head, I'm thinking about major bankruptcies in 2008, 2009 of companies that have been around for hundreds of years in the US, for example. So they used to be extremely efficient, everybody used to love them, they did the right thing for a really long time, and then at some point they became inefficient and too big. So this long run average total cost line is what we like to call the planning curve. All right? So most companies experience economies of scale as they grow, and economies of scale, no wait, we can do better. So economies of scale are basically when your long run average total cost decline as you produce more. So the more and more quantity you produce, and to use the example of the pizzas, you know, the more and more pizzas you produce, I want you to think about Pizza Hut now or something like that. So the bigger you become, the cheaper it is per pizza. At some point, that ends, and then you go into these economies of scale. So this is what we call the long run average total cost. Okay, so you experience economies of scale for a really long time, and then you experience these economies of scale after that. All right. When you are experiencing economies of scale, also known as increasing return to scale, is a situation in which the bigger you are, the cheaper it is to produce. Constant returns to scale is a situation in which the bigger you get, production costs neither increase nor decrease. Minimum efficiency scale is when all level of output which economies of scale are exhausted. So minimum efficiency scale is this point here where you have exhausted all of your economies of scale. And then you enter these economies of scale, or what we call also decreasing returns to scale. This is a situation when a company tries to continue to grow and it actually gets more expensive the bigger they are. All right. These are different graphs, by the way, of how economies of scale may pan out for particular companies. Some companies may see economies of scale very quickly and then kind of like go into this constant returns to scale and then see these economies of scale towards the end. Some companies may see economies of scale that last for a really long time and then at some point a major bump on the road. And then some companies exhaust their economies of scale very quickly. So they cannot get any bigger than a certain amount because economies of scale don't help them as much. All right. I hope this particular chapter was helpful, understanding technology, the production function, and the costs of production. All right. The biggest takeaways, by the way, from this particular chapter that you need to remember for subsequent chapters is you need to remember the differences between short run and long run, and you need to remember the cost structures for companies. So you need to remember this slide here where we graph average fixed cost, average variable cost, average total cost, and marginal cost. Thank you for hanging out with Professor Choi for another lecture. Have a good one.